My evil plan's almost complete. Mathematics will be ruined. No one can stop me now. I am going to prove a flaw in set theory. Of course, my proof isn't true, but with a little manipulation, no one will ever know. No one will be able to find the error in this proof.
Oh no! I have to stop him. Who can help me? I know. Heidi and Caitlin. But I have to keep our communication a secret, or else Dr. Bosman might find out. Oh, I've got it! I'll send them a coded message. It has to be one that no one else can decode. What codes do I know? Oh, I'll send a Playfair Cypher.
Hey, what does your code say? Oh, what it says is the name. I'm not sure what this is. What's yours saying?
It's just a bunch of friends and letters.
Do you know what that is? That's a Playfair Cypher!
Playfair Cypher?
You mean the one invented by Charles Winston in 1854 to send his messages in secret over telegraph, but it's actually named after Lord Playfair, who was the one to promote its use? Would that also be the one that was initially rejected by the British Foreign Office because they thought it would be too complex to learn, even though Wheatstone offered to demonstrate that 3 out of 4 schoolboys could learn it in 15 minutes?
Yes,
And wasn't this also the code that J.F. Kennedy used in World War II to send a message to the Australian Coast Watcher, Lieutenant Arthur Reginald Evans of the Royal Australian Naval Volunteer Reserve, to alert him of the attack on PT-109, which was then decoded by Evans and saved the lives of the men aboard Kennedy's ruined ship?
Okay, yes, Caitlin, I don't need a history lesson right now. What we're gonna do is solve this.
Okay, fine. Well, since you're so smart, how do you suggest we do this?
Well, I was gonna tell you, but you kept interrupting. So now that you're listening, pay attention. The Playfair Cypher consists of strings of pairs of letters like this that we found in our message. And to decode this message, you create a 5x5 key, which is created using a code word. So say, for example, we have the code word monarchy. Now you have to be mindful that our key has only 25 spaces since it's a 5x5 grid, so you can't create a code word or a code phrase that is longer than 25 letters. So you also have to avoid using repeated letters. So say, for example, your code word was hammer. Since in the key you only use every letter once, you would have to replace this M with an X. That way you use each letter only once. And if in your code phrase you have repeated letters that are used multiple times, then the first time you replace it with an X, and the second time that letter appears, you would omit it altogether. So for example, we have the code word monarchy. So how you would fill this in is you would start out by filling the code word from left to right, top down. So we put in our first letter is M. And then we would fill in the rest of the key using the alphabet, the letters that haven't been used yet. So we've used A, so the next letter we use would be B. And then C, D. So here comes the part where since we have 26 letters in the alphabet and only 25 spaces, we have to take out one of the letters in the alphabet to accommodate for that. So we choose to take out the letter J. Now if we encounter a J in any of our messages, we just replace it with the letter I. So here we're going to skip J, and we'll put K. So now that we've created a key, all we have to do is encode our message. So for this key, I'm going to encode the message, math is awesome. So to first start encoding our message, we first have to put it in pairs of letters. M-A-T-H-I-S-A-W-E-S-O-N. And you see we have a leftover E that doesn't have a pair, so we pair this with the letter S. Whenever we're missing a pair. So now we go ahead and encode it. So our first two letters are M-A. So I'm going to circle them on our key here. So we have M-A. As you can see, this forms a row right here. And so the way we encode these is we shift the letters over one space. And which direction we shift them depends on which letter's first. So since M is first, we're going to shift towards the second letter, A. So M is going to shift to the right, and A is going to shift to the right, giving you the message O-R. So next we pick the letters T-H. So T is here, and H is here. So if you notice, T-H actually forms a rectangle. And so to encode this message, you actually just switch it to the different corners of the rectangle. So T would switch to P, because T is first in our code, and then H would switch to D. So our encoded message for TH would be PD. So our next two letters are IS, and so they're right next to each other in a vertical line. So the way we encode this is the same way we encoded the one that was horizontal. We go straight down by encoding it. So IS encodes down, since I is first, I will go down, encodes to SS. So as you can see, AW forms another rectangle. And AW is going to also encode to the other corners of the rectangle. AW encodes, since we have A first, A goes to N and W goes to X, so our encoding of AW is NX. Our next two letters are ES. This this forms another rectangle, and E, since it's our first letter, will encode to I, and S will encode to L. So ES encodes to IL. Our next two letters to encode are OM. This one's going to be a little bit different than the other ones and a little trickier. But OM, since we start with O, we have to go that direction so we know which direction to encode it. So O is going to change to M, but M is actually going to go around basically and change back to R. So the encoding of this, of OM, could actually be MR. So our final two letters are EX. And as you can see, EX forms another rectangle. And so, as we've been doing before, the E will encode to I and X will encode to U. So EX becomes IU, and that's your encoded message. And then all the receiver of the code needs to do to decode this message is the code word. Then they can recreate the key and do the process we just did backwards.
Seems simple enough, so let's decode it.
Okay, but first of all, we need a code word.
How are we supposed to find that? There's literally a countless number of words in the English language that could be it.
That's where your brain comes in this message. So basically, I think that the name is telling us that this is the code word, but I'm not sure what this string of letters is.
Oh, that's easy enough. That's the decimal system.
Oh, so this is in a library. This is a library book?
Mm-hmm.
Yeah, let's go.
Let's go.
So for this code, since we have an even number of letters, 6, and we don't need to replace any of X's, then we can just go ahead and write our key. So we put our A here.
So you just replace I with J when you need to, right?
Yeah, if they encode the message and there's a J in the message, they'll just replace that with I. So now we can go ahead and decode our message. So basically we just go backwards. So I would take my first two letters, and this is U, W, see? And since when you decode it, you go down. So when you encode it, you go down. To decode it, you have to go up. So we go up. From here we go M. So it's U. So it's U, W. We go M, A. So our first letter would be M, A. And then we have C, I. So C and I. So since it makes the rectangle, we choose the opposite sides in the same order. So we have T and H. So TH would be our next two letters. So now that I have my decoded message, I can see I have X's in here, but these are just the repeated letters. So you can just take this letter and change it to an R, the one preceding it. So like X, this will be an L here. And then this one would be a T here. And then we can ignore the last X, because that just means it was uneven letters. So we can ignore that. So now what does this say? We've got math world in danger, looks like. This looks like ring bell 15 to alert the, looks like this connects here, students. I'm gonna write it here. Students, keep looking up. Math world in danger? What is that supposed to mean?
Whatever it is, it sounds urgent. I should probably get this figured out as soon as possible.
Ring bell 15? There's no bells on campus. What are they talking about?
Bell hole. Bell hole.
Oh! It means it'd be room 15.
Okay, let's go. Dang it, it's locked. What do we do now? What did the note say at the end?
Keep looking up.
Oh, there it is.
Oh! It says, Michigan is not my home, although I am always warm. 4 walls of glass are all I see, but you can never see me. Hey, I wonder if this cipher works with our key that we made.
We can try.
This doesn't make any sense.
Yeah, no. Hey, I wonder if this is the clue to the next keyword. Michigan is not my home, although I am always warm. Well, it'd have to be inside because it gets cold in Michigan. 4 walls of glass are all I can see.
Is it like a tank or something?
Wait, the Yaku tank at the science complex.
Oh yeah, that's it!
And nobody ever sees them.
Let's go!
They actually do exist. I've literally
Come on,
never seen
let's look
these
for the
before.
code.
Is this it?
I think so.
Yep, time is ticking. Let's make a new grid.
So here our code word is time is ticking. So how would we write our code phrase? So T-I-M-E, there's no repeated letters, but when we come to I, that's a repeated letter. So we have to replace it with X, S, and we've already used T and I, and we haven't used C, so C, K, but we've already used I, so then you have N, G. So now that we have translated our code, now we can put it in our grid. So now we just have to replace these X's. So this would be R, and this one would be E, right? And then that one we can ignore. So
Alright,
our message is
please hurry. 2 male cows need a lift. What?
2 male cows. They could have been more imaginative.
Wait, buller, as in Buller Hall?
But, so would the 2 be like the room number?
Well, Buller Hall doesn't have a room 2, so it must be referring to the floors.
And then need a lift? Like the elevator! Let's go! Yep, it's here. But we don't have the code word.
Well, maybe try one of the other ones.
Okay.
Hey, Heidi, just got a text message.
I think I did too.
The end game.
Who cares about Avengers right now?
I don't think it's talking about the movie.
So what are you saying?
I think it might be the code phrase.
How do we know this is the code phrase?
Well, think about it. You and I both got a text message at the same time. It can't be just coincidence.
you think someone's watching us?
Just try it. It might work.
Okay, I'll try it. Hey, it worked! Here.
The man villain is a boss. You will find him munching on snacks. Please stop him before he sends out the message.
This must be the final message. We must be almost there.
Bosman! Dr. Bosman is the villain!
What? Where'd you get that idea?
Think about it. The man villain is a boss. Bosman.
Oh, that makes sense now that you mention it.
I don't understand that about him munching on snacks, though.
Even I can get that, Caitlin. He's always in Karen's office munching on her snacks.
Heidi, you are a genius.
Let's go. We gotta stop him.
We know what you're trying to do, Dr. Bosman, and we will not allow it.
How would you even think of throwing a math roll with a false proof?
What are you talking about?
You know exactly what we're talking about. We know that you're planning to destroy the math world.
No.
There, it's all deleted.
What did you just do?
I deleted the false proof that you were going to use to destroy mathematics.
No, I was making a fake video. You must have misunderstood. It was a joke, April Fools. We were going to find a mistake in the proof. It was going to be fun.
Then what did I just delete?
It's my calculus exam.
Oh, Dr. Bosman, I'm so sorry. We did not mean to do that. Sorry, Caitlin. I'm glad Dr. Bosman isn't an evil villain after all.
Yeah, I'm not quite sure what we were thinking we were going to do when we got in there.
Oh, hey, Autumn. Hey, guys. Did you like my code?
So it was you that sent us on that wild goose chase.
Well, you know, I had to be kind of sneaky so Dr. Bosman wouldn't figure out.
Well, you realize anybody could figure out those codes if they wanted to.
That's impossible. There are so many words in the English language. There's millions of possibilities.
Well, I mean, there are 25 letters in each grid, and each letter is paired with one other one, so wouldn't it be like, what, 15 possibilities?
So almost, Caitlin. But if you think about it, if you have a 5x5 key, the first letter is going to have 25 options. And the second letter is going to have 24 options because you can't reuse the first letter. So you'd have 25 times 24 times 23, which would be 25 factorial.
That's a 6 with 23 zeros after it.
Yeah.
That makes sense.
Okay, but not actually because we have a grid that's 5 by 5. So if you rotate each grid, you're going to end up with 25 equivalent grids. So it's actually 25 factorial divided by 25, which gives us 24 factorial.
Exactly.
Okay, but that is so long. Is that possible that anyone could do it by hand?
So from what I remember, there's no way to actually find the code phrase in order to decode it. However, what you can do is build a dictionary. So what you would do is make a whole bunch of different grids with a whole bunch of different code phrases and then write down the pairs of letters. And once you have enough, you can cross-reference them when you have a message. And that's almost as good as having the original code phrase.
But that would take a really long time and a lot of figuring. Isn't there like an easier way, like using a computer?
Okay, actually I just googled this. So when solving by computer, an easy way of finding a key is to start with a random square of letters. Minor changes are then introduced, like swapping letters in the key, to see if the candidate's plaintext is more like the standard plaintext than before the change. So you could like use Markov methods or trigrams, frequency counts. Anyways, if the new square is deemed to be an improvement, then it's adopted and further mutated to find an even better candidate. Eventually, the plaintext or something very close to it is found by choosing the key that provides a plaintext with the highest likelihood. Another way to solve this would be using the simulated annealing algorithm. It's basically the same thing as above, but the computer eliminates the possibility for error by allowing for an occasional deviation from the key that is close to an English translation, so you can avoid hitting a false answer to the key before you have really solved the decryption.
Wow, that's complicated.
But it is feasible to think that you could decode a message without having the code word.
That's true, and that must be why it's not used for any real correspondence anymore.
Yeah,
Makes
that makes
sense.
sense.
Hey guys, what's that?
Oh no, not another code!
Bring it back.